Welcome to episode 45 of the Adam Makes Beer Industry Pro podcast. Today, I'm excited to be chatting with Shane Bird, production manager at JuneShine, Eric Dean, North American sales for Dalum, and Peter Dahlen, director of brewing operations at Sebago Brewing. Before we get rolling, let me give a shout out to our fantastic sponsors that make content like this possible. Starting a brewery is a big step. Blickman Engineering is here to help. Since 2006, they've equipped hundreds of nano breweries for success. Their new 3.5 barrel Pro Surface electric brewing system cuts maintenance and saves at least 30 minutes per brew day with powerful under kettle heating. From 1 to 15 barrel brew houses to keg washers and grain mills, Blickman has what you need. Ready to go pro? Contact Phil or Tom or at Pro Series at blickmanengineering.com. Blickman Engineering is a proud sponsor of this channel and loves to help brewers at every stage of their journey. Tracking and managing the financial health of your brewery is a primary pillar of success. Check out my boy David Lentz at Brewed Fiscally. This man has the industry experience and skills you need so you can focus on growing your business. Bookkeeping, fractional CFO support, financial management system design, business plan review, hit up your boy. Check him out at brewedfiscally.com or shoot him an email at david@brewedfiscally.com. He's good people. I've said this the last 4 times I've done these live reads, gentlemen. I wrote one and somebody else wrote the other one. I don't know if you can tell. One may seem a little bit more informal. But anyways, there's that. And these guys that I'm talking about, as I mentioned before, I'm excited to be talking with Shane Bird, Eric Dean, and Peter Dahlen. Gentlemen, welcome to the show.
Good to be here. Thanks for having us.
Absolutely. So if you just want to go around and give everybody a quick introduction, what you do, who you do it for, things like that.
Cool. I can start if you don't mind.
Go for it.
Yeah, my name is Shane Bird. I'm the production manager at JuneShine here at our Scripps Ranch facility in San Diego County. I started in the industry as a busser in 2016. Kind of worked my way up at a couple different breweries here in town, and then more recently just been with JuneShine for coming up on 5 years, and it's been a wild ride getting into the beyond beer space. I did make beer professionally for 4 years prior, and excited to be here.
Nice.
Thanks. My name's Peter Dahlen. I'm the director of brewing operations at Sebago Brewing Company. We're a brew house just outside of Portland, Maine. We started up in 1998, and I joined the team in about 2008. Our production ranges from around 10,000 to 12,000 barrels annually. And we also have 4 attached restaurants that we service, each with brewery licenses. But our central facility has a 4-vessel, 40-barrel brew house. And we primarily distribute in Maine and sometimes a little bit outside of New England. But most of our product is right here in Maine. And, I've been in the industry, I guess, for about 16 years or so. And I started as a humble home brewer in the mid-2000s.
Excellent.
Yeah, Eric Dean, primarily 20 plus years in design and build engineering, primarily automated equipment. Jumped into the craft beer industry around 2016 at a craft beer bar in beautiful Algoma, Wisconsin. 20 some odd beers on tap and another 50 plus in cans and bottles. And then worked for Canopy Brewery as a GM. The Nick was a little different, so I started on the floor. So I've swept the floors and cleaned out the mash tuns and cleaned the kegs and everything else. And this opportunity with Dalum presented itself, and coincidentally, the Kudrowskis are right there in Algoma. So also had a background in national sales, so it just kind of fit, and been at it now for the last 2 years with them.
Sure. And this whole topic of CO2 is so interesting to me, because if you would have asked me about it, well, even quite recently, I would assume that it is something that is strictly for like the largest of the large craft breweries. And so to find that there are some solutions out there where there are, breweries of a smaller size that have access to equipment like this now. I think that's a little bit of an eye opener. Eric, can you dip in a little bit and kind of explain, a little bit, I think, obviously we know CO2 recovery is important, but what are some of the benefits of that? Maybe some of the things that you don't quite expect when it comes to the benefits of that.
Yeah. Well, I mean, CO2, every brewery's, you're discharging CO2 on a daily basis, every time you're fermenting. Larger breweries for years have been able to capture that gas and turn it into liquid and then be able to reuse it in the facility. So from every brewery, distillery, winery, they're capable of doing that. So it just makes sense that if you can capture that gas, liquefy it, and turn it into usable CO2 for your brewery, it's good for everything. It's good for the environment. It's good for your brewery. It helps to, eliminate ROI or eliminate costs on your CO2. It makes sense. And then having it, Kim had Dalum, who was the founder, recognized that from the small brewery standpoint, for microbrews and craft breweries, it's there. You're doing it every day. You're discharging the CO2, so why not capture it and be able to reuse it?
And so what are some of the smaller places that you have a system like this in?
Small as well. It's right. We have breweries of all sizes. We like to say, if you think you're too small, you're not. I'm, right now we're in the process of negotiating with a brewery. They're only 800 barrels.
Yeah.
The beauty of a Dalum system, and not from a sales pitch or anything, but we literally can accommodate, even if you want to produce your own CO2, we have a system that'll work for you, is what it comes down to.
Sure. So are there like multiple different units that you have, I'm assuming then?
Yeah, presently we have 4 sizes. We have a micro, a mini, a craft, and then just released a senior. One of the first seniors was just installed in a brewery in Germany just recently. So basically 0 to 5,000, 5,000 to 10, 10 to 20, and then 20 plus 1,000 barrels. We have just recently sold 3 units into a brewery in Windsor, California. That's they about 30 plus 1,000 barrels. So they'll actually be using 3 of the senior units in that facility.
Okay.
Yeah. So you can use them in tandem. So as you grow, we can actually, our system can grow with you.
Sure. So Shane and Peter, kind of functionally, or like, I don't know, as somebody that works with this equipment, what were some of the initial questions that you had when the conversations first started, kind of surrounding, making the acquisition on something like that?
Well, I'm happy to jump in on that. And like Eric was talking about the scalability of this. When I first got into brewing, I did a lot of the MBAA, Master Brewers Association of the Americas meetings. We have a pretty strong chapter here in New England. And I remember meeting up with some of the Anheuser-Busch brewers at their Merrimack, New Hampshire facility, which I think is one of their smaller facilities. And they were just kind of coming online with a CO2 recapture system at that point, which was maybe 2010 or sometime around there. And I remember that being a really big deal for them. And I thought that was so far out of the picture for a group like us at that time. And, clearly we're just a fraction of their scale. I always thought the technology sounded amazing, but it seemed like something that was, it would never be scalable to a brewery like our size. So I hadn't even really considered it as an option again until probably 21 or 22, which was right around the time when there was that CO2 crisis, where breweries were starting to, get pinched on availability. So that kind of restarted the search to see if that was something feasible. And it was brought to my attention from I think one of our hop suppliers from Crosby Hops at the time that had seen some other facilities that were starting to do CO2 recapture. So my initial questioning was, oh, well, is that available for a brewery our size? And I don't remember which brewery it was that was doing it, but our supplier said that they were smaller than us, and a lot changes in 10 years, and critical shortages drive inspiration as well as other opportunities out there. So some of the questions that we had, first of all, were are there scalable options that actually meet our size, and then cost, of course, and then the quality behind it. So those were kind of the three things that really started to make us reinvestigate if this was an opportunity. And I'm not sure, Shane, if that's a similar sort of situation when you folks started to investigate those options. But I've heard other folks as well that have kind of started to reconsider things around that time.
Yeah. So I think for us, around the CO2 shortage is when we kind of really got serious about it. We at JuneShine had always really talked about being self-sufficient from a sustainability standpoint from day one back in 2018 when we started. And then when all the CO2 shortages started to happen, we, along as with many other brewers, learned about force majeure, which is on your CO2 contract that in the event of a shortage, the supplier can actually determine who gets what based on who they want to give it to. And they're going to probably give it to the higher spending accounts than the smaller guys. So at that point, we got really serious in looking at the Dalum unit and any kind of CO2 recovery that we feel like we could find. And I think the two most important questions were cost and space, which I think most craft breweries that would be their number two priorities as far as like getting any new kind of piece of equipment.
Sure. So the unit itself, is that something that is going to be inside the building? Is that something that can be outside the building? Because I know brewing spaces are notorious for being packed to the gills with as much tank space or storage space or, what have you. What are the parameters as far as having that unit inside or outside of the building?
I'll jump in on that. I mean, primarily inside is best. I mean, we will operate under different temperatures. We do have situations where a brewery is having to put it outside. In that instance, basically, an enclosed area. The extreme cold is far more detrimental than a little warm. But for the most part, there's very few moving parts on the plant itself. So, and it is brewery top. It's not that it can't have water or what have you, splash on it, but just an enclosed environment is the best for it. It does have electronics, UL panels, and what have you.
Sure. So you have this thing stored inside your brewery. So if we were talking about, the smallest unit that you have, what are you looking at? Kind of, how tall is it? What kind of footprint does it have?
Basically 12 square feet it's essentially the size of the pallet. All four units are the same, that same platform. Your height does differ. You go from 108 inches on a micro through a craft. Once you get to the senior, it's taller. You're primarily 110 feet. And that's to accommodate the scrubber that's on it. So we need a little more height on that, obviously, based on the flow of gas coming through.
Okay. You talked about a scrubber. What is the scrubber?
Scrubber, basically, think of it like as I like to explain it as a big bio scrubber. So a lot of the gas as it's coming in, basically as the gas is passing up through a cylinder, there's a water wash that comes down through that. And that water wash will essentially eliminate about 95 to 96% of your odors or any anything basically that's coming through the gas that makes it to that point. So it's very efficient as far as that.
So pardon me if I didn't understand correctly, but so what are the utilities that would this unit need to have access to? Obviously it needs electricity, but you also just mentioned water. Does it need to have a water input as well?
Yep, you're gonna need water, just regular tap water.
Okay.
Yeah, Peter, that'd be great.
Yeah, and the utility access for it for our application was fairly straightforward. Like Eric said, we've got a 1/2-inch water line going to it that just comes off our regular domestic water. Doesn't need any hot or cold treatment. Ours is just our ambient, locally supplied water. Has an inline filter for it just in case you have any particle sort of situation in there. It taps into your existing glycol system. So we had some existing drops that were accessible to where our machine was placed. It needs CO2 access from your fermenters that just enters the machine through a braided nylon hookup, unless you want to attach a different one on there. And then, like Eric had mentioned, the electric as well, which it's not a terribly demanding sort of thing. It was 240 volt, maybe a 30 amp breaker on that for our system. And I believe that's about it. And then drainage. So just access to floor drain or some other port for any of that scrubbing water that Eric was mentioning.
Sure. So one of the first things that my mind goes to when you start discussing something like this is obviously there's going to be some hookup from the fermenter to this unit. And one of the first things I think about is because so many people are making hazy IPAs these days, and with some yeast that like to be very lively, and people like to fill up their tanks as much as they can to get as much volume out. How does that work? So I'm interested in the connection between the fermenter and the unit, and then also how do you kind of factor in the fact that at certain points potentially you could be pushing krausen and yeast out of that tank? If somebody can talk to me about kind of the metrics surrounding that.
Yeah. So obviously for beer producers, you would have to kind of pick and choose. Maybe some of your styles of yeast will work. Some of them may not. You typically do need to ferment under pressure at some point, but it's a very low pressure. So you're definitely going to wait to hook up to the unit after the high krausen stage. So 2 to 3 days into fermentation, once things have slowed down a little bit, that's when you can basically take your blow off instead of going into the sanitizer bucket. And like Peter was saying, you can then attach it to the unit via braided nylon. I've seen breweries have hard piped it. If you want a more permanent setup, we just have a big PVC pipe loop that goes around our cellar, and then we will attach a nylon hose to that drop that goes to our unit, which is outside. We are in Southern California though, so we don't have any issues of any elements having our unit outside. Sure.
And so, I could hop in and say how our system is slightly different. So we're up here in Maine where it's too hot out in the summer and it's too cold in the winter to have this unit even placed under a sheltered awning would be tricky for us. So our unit is inside, and we hook our fermenters up. We have a device that we kind of cobbled together that we're looking to improve, but sometimes we will start collecting as soon as 5 to 8 hours after our last knockout for hooking up. And this sort of thing, it's great to start to talk to other folks that have recapture systems to kind of compare notes, which I look forward to more people getting online with this sort of stuff. So we leave more headspace in our tanks for our hazy IPAs like you're talking about, because we know they go all the way up. So over the past several years, even before having CO2 recapture, we've tried to figure out, at what point do we start going over and then, back off one. kind of a deal. So we don't have a lot of foaming over these days. So we can hook up earlier and try and start capturing, the gas as soon as possible. However, if you were to get some foam that goes over, depending on how you choose to set this up, you could end up with some of that, Croissant foam fouling some of your collection lines or some of the spunding and check valves that are in line. We've seen that I think only once with what we've got, where it ran out of our blow off hose into the spunding valve that then kind of connects to our collection network that feeds the Dalum recapture. But really it just meant closing a valve and cleaning up one of these adjustable PRV spundings valves. So it was fairly easy to clean. But I think if you run the risk of sending a lot of foam through, then you'd probably want to set things up a little bit differently to either start collecting later or put some sort of device in or tank in to buffer that foam before it really starts to get closer to the unit itself. We have two separate buffer tanks that are just old single wall serving vessels in line, just because we had them and we were concerned about sending foam in, but it hasn't really been an issue. And just having those vessels is a little bit of insurance, and it also helps to buffer and increase our collection and process time for the CO2. But like Shane was saying, we have it's a manifold that we can feed multiple tanks into, and then that hose kind of feeds these tanks and then runs all the way to the unit itself. So you can have multiple tanks hooked up, as long as they're not generating too much. You can feed the machine, and then it'll process it as it becomes available.
Yeah, that's really interesting. So there's a couple of things that my mind goes to. So it sounds like in order to do this, do you have to have a spunding valve on every tank that you're capturing off of?
I would say so. I would recommend it.
Sure.
There are spunding valves basically on the machine that if your output isn't a lot, it could handle it. But Peter, you might be able to detail this more, but if you're hooking up multiple fermenters to try and recapture at the same time, then you need to kind of gauge the flow really well to the machine, because it has to be within a certain range for it to recover as designed. It can't be too low and it can't be too fast.
Okay.
Yeah, and so for our system, we're our biggest tanks are 160 barrel fermenters, and a busy week of production for us would probably be 2 160 barrel batches and then maybe 2 80 barrel batches in between, on which we also have 80 barrel tanks. And we get most of our collection, again, starting, in the middle of the night after the last knockout of a 160 barrel brew. We can time that for say 5 to 8 hours after we do knockout, and it'll begin collecting. And our fermentation for our, ales there, it's usually about, 3 days after that, we're at terminal. So we go pretty fast with our system or with our fermentation profile, but we will still connect another tank on the following day, so another 24 hours. And there still is capacity with the unit that we have. Eric helped scale us that so that we could do these brews in succession and be able to continually process the CO2. Like Shane was saying, having spunding valves or check valves on each of these tanks, we felt important so that they're not interacting with each other. The spunding valves on our manifold essentially work as check valves as well. So if you choose to have different pressure settings for your fermentation profiles, each one is individually adjustable. So we have 4 different spots to hook in. Each has its own spunding valve, so that we can have 4 different tanks feeding the system at the same time. And whether we choose to have a couple of them ferment at the lowest setting, which is 0.2 bar, that's the lowest setting that the Dalum will process CO2, or we can choose after primary fermentation is done and we want to spund our tanks to keep as much gas in solution in the fermenter, we can then adjust those spunding PRVs to 1 bar. so that it'll retain gas in that tank all the way up to 15 psi. But anything over that will bleed into the collection system and then be processed.
Okay.
And for us, we had already been in the process of spunding for, a couple years before we got into this with just regular atmospheric or spunding valves that bleed to atmospheric pressure.
Mm-hmm.
So these were new spunding valves to us, but they essentially worked in the same fashion other than being able to direct that excess gas to a specific spot instead of just bleed into the brewery. So changing over from the process we were doing before for the beers that we were spunding was a fairly straightforward process on some of those, but we had to adapt some of our other beer styles to collect throughout the entire fermentation, which we had not been doing. Previously, we had just been adding the spunding valves towards the tail end of fermentation.
Okay.
But again, with these adjustable ones that Eric sourced us, you can choose that under pressure setting to meet whatever those needs you're looking for.
Sure.
Yeah, and on that note, spunding is ideal, but we do have breweries that are just straight atmospheric. We were talking about foaming, and we actually sell the foam trap also can act just as a pressure vessel. We have one brewery that one of our first installs here in the States. They're just straight atmospheric, and basically they can have multiple fermenters. The manifold is actually on the foam trap, and so as the gas comes in and it's building up pressure, the PRV valve on top or on the foam trap, if it overpressurizes, it's going to release, it's going to bleed atmospherically in any case. But because we have a variable frequency drive on our compressor, it's just looking for that flow of gas. And like Peter was saying, once it reaches that point too, it's going to start pulling it through. So if you don't want to ferment under pressure and you just want to go straight atmospheric, as long as the question to ask also is when you're looking at these is the questionnaire doesn't cost you any money. If I send you out a questionnaire, go ahead and answer it to the best of your ability, because what that allows us to do on our side is create a CO2 curve in essence, and take a look at your brewing schedule and what your peak fermentation and collection times are. Because that will help us size the correct. I mean, you might be a smaller brewery, but because of the way you brew, you need a larger system because of your peaks. So yeah, spunding is ideal, but you can absolutely just do it atmospherically.
Okay. So and maybe this is just the brewer in me talking, Shane, but do you have to purge? Because in my mind, every time I'm moving anything, almost anything, you want purged vessels, whether it be transfer lines, however you get that done. So when you are hooking up from your fermenter to up to the CO2 recovery system, do you have to push that or bleed that atmosphere out of that system, or does that system just handle the atmosphere in it and then just start collecting the CO2? Does that make sense what I'm asking?
Yeah, you're kind of saying like, we're kind of talking about, we have these pathways to the machine itself,
yes,
whether or not it needs to be purged.
Yes.
The other guys could comment, but I would say no, it's not necessary. It's going to go into the foam trap, and you're going to have that PRV. And once you're, in our experience, because we're waiting until after Heikrausen, so a couple days into the fermentation, that blow-off valve is pure CO2. We're talking less than 15 parts per billion of oxygen in that blow-off. And so, yeah, in theory, you might get some oxygen in there, but it'll get scrubbed out when it's cleaning the gas.
Yeah, and we've played around with that a little bit, and like you're saying, Adam, as a brewer, whenever you're doing a transfer or something, you're like, oh, I've got to cover the valve up, or we need 3 valves on this hose, and we got a triple purge between each one. And it's like, so that was a lot of our team when we're going to change these hoses around. It's like, we're going to need like 100 more valves to close off all these hoses when we move things. And we were told that we didn't need to do that, but we're super cautious with that sort of thing. And we've tried that. And so the machine itself has oxygen sensing in it, and it it reads that throughout the process. So it knows when there's too much, or it knows when there's more than it can safely proceed in the process with, or that will actually work in the process. But most of the time we've found that it doesn't even get to that point. If you have a hose and you're moving it from one tank to the next tank, and you're dragging it across the cellar, and it's just in your hand, and it just came from an environment that's pure CO2, you can move it to the other tank that's already primed in CO2, and that amount of atmosphere ingress in our system we have 12 barrels of buffer space. If there was air pickup in there, the O2 pickup is so minimal within the buffer space that we have that it does not impact even a small reading on the unit itself, which tracks the O2 levels as you go. The bigger thing that we've seen is when we hook up a tank too early, because that's where we're at right now. We're trying to really start collecting first thing, and again, like I was saying, most of the time that optimal time is when we are not staffed. So we don't have anyone camping out overnight checking the blow off hose every 20 minutes to see when it goes to 0.6% O2, and that's at the point that the machine can start compressing that gas into CO2. So again, we've worked that timeline backwards, and we have a timer set. So like, all right, we'll try 8 hours after knockout, 6 hours after knockout, 4 hours after knockout. Oh, 4 wasn't long enough. And what we'll see is that 12 barrels of buffer space that we have, and we can look at this on the data tracking that the portal for the Dalum has. You can see the level of O2 start to climb as the pure CO2 environment that was already in the system. You can start to see that go up and out of range as it pushes too much O2 into the system, at which point the compressing stops and it valves an exit for that gas. So it essentially puts the system into a standby until enough of that O2 and that gas that is too high in O2 is removed from the collection system. And then as soon as it drops down back to that 0.6 O2% level, then the machine will start back up and resume compressing. And I think one of the big questions I get a lot from folks is, wait, so you're comfortable with 0.6 O2 in your CO2 that you inject into your beer and your tanks later? And that's something important to differentiate, is though, even though you can safely move forward with 0.6% O2 for the way the system processes, it doesn't get carried through to the finished CO2 product. And that's something Eric could probably speak better to about how exactly that works. But the range that the system can operate and safely produce that pure CO2, that starts at 0.6 O2. Generally, once we get our system running, it collects at 0.0% or 0.1% is where we see the system fluctuate the most.
Sure. Yeah. Go ahead, Eric.
Well, no, I was just going to say there's several different ways you can do that. A lot of your, most of the breweries, you're using a lot of the same yeast strains, a lot of the same wort streams and what have you. And generally, once you get once you get your timing down on that wort stream once, it's not going to be 99% identical, but it's going to be pretty close. So if you say, hey, at 14 hours, I can hook this up. Peter, I'm glad to see you're pushing the envelope there on the shorter span, but that is the reality. And I mean, we can't tell you guys how to brew, and your breweries, and if you know that this is the time to do that, this is the time to do it. But one thing that we have actually developed what's called a set and collect. We don't have it out yet, but it's basically a timer. So you can literally set this timer on a fermenter, and once the timer goes, it's spring loaded, it opens up the valve. And so it is a Saturday when your prime collection is, you can guarantee that, at that time it's going to open up and gas is going to be coming in. And like Peter said, the PLC and the system itself the plant itself is going to handle the rest of it. If there's too much oxygen and it opened too early, yes, it may contaminate some of the pure gas that's already going through, but the system's going to know enough to, hey, I have to vent this right now. and then it's going to monitor it until that it is at that purity level, and then it's going to start pulling it back through.
Interesting. So, one of the things that one of the reasons why I love having conversations with different people on this podcast is your brain starts working. And something that has started clicking in my brain right now is, as brewers, we think about all the things that are generated during the fermentation process. We think about alcohols, we think about flavors and aromas, we think about heat, right? Because we have our glycol system that's going to be managing the heat of fermentation. But I've almost never considered the CO2 output, and we've talked about it a little bit. So on the production side, I was just realizing I don't know what those windows look like. Like, I know functionally what's happening in the different windows. Okay, so my yeast is in lag phase, growth phase, or whatever. So I know it's taking up oxygen, multiplying X, Y, and Z, right? But really, what is that? Where do you see that? And where do you see it first start really producing? And then how long into that process, how tied to, are we talking bell curve, but how tied is it to we hit terminal, and that's terminal gravity or terminal density, and then that's it? What do you speak to kind of what that window of collection looks like for a standard fermentation?
Yeah. So I think Eric said a kind of cool comment that I didn't know we could just do atmospheric recapturing. But that kind of brings me back to kind of how we at first initially looked into, okay, when do we want to hook up? And I think it's safe to say if you're looking at purchasing a CO2 recovery system, you probably have a DO meter somewhere in your facility. And the easiest way to identify when you can hook up is just to take a DO reading of your blow-off valve before you hook it up. And that will let you know how much oxygen is in there. And it's up to you as a brewer to determine what is your acceptable rate and like what's going to go into the machine.
Sure.
Yeah, and I would say we still do that right now, and we've been running since September. And between all the different tanks we have, the different yeast strains we use, and fermentation profiles, and multi-turn versus single turn, and this is our slow season, or we're just getting off of our slow season. And so when we do a 40 barrel batch in a 160 barrel tank, the timeline is it's not the same. And when we're doing a harvest pitch versus a Gen Zero prop brew, like these are things that we're finding it changes the timeline of when you can capture. And like Eric's saying, when we have our batches that are standard, the wort stream and the yeast that we do, we feel pretty confident when, we put the 80 barrel batch in an 80 barrel tank with that same beer. We do that every time. It doesn't deviate very much. And we do like what Shane says in the early stages, we'd use a DO meter, and you just measure the gas coming out of the blow off, and you can see it. And when you're there during the day, you can measure that. But finding all those different curves for each of your different beers and your combinations with the tank geometry, we've seen some, they're not surprising, but they are important distinctions that we've had to try and figure out. And, it's when you do these things, it's like, oh, well, we're not making that beer again for another month, and maybe we'll make it twice as large next time in a different tank. It's like Eric says, it's like they can't tell us how this is all exactly going to work because everyone's batches and configurations is slightly different. So, making sure that you've got the ability to have someone that's going to take that on and figure out what these points are, because there's, the map is different at everyone's place. But, again, for us, a lot of that capture time is right in the beginning, but we still continue to capture once we've reached terminal. If there's capacity in the machine, we just leave the tank hooked up. If we have an IPA that we've dry hopped and it's going through just a warm dry hopping, and it's up to 70, even though it's at terminal, it's still going to have some gas breakout even if it's at 15 psi. So we'll leave a hose hooked up if we don't have anything else hooked up to the machine, and we can watch it on the graph when we'll see, oh, well, we didn't really have any active fermentation, but there's a spike with the machine that started running overnight. It ran for 20 minutes, and then it kind of slowed down again. And what it is just that some of the gas broke out of the beer in the tank enough to pop through that spunding valve, and it pressurized the system enough to collect for an hour, and then it stalls out for another 2 hours, and then it might capture again. So it's not the main part of the recollection system, or it's not where most of it comes from. But there's those little bits and pieces. If you leave it up, it can still collect even when fermentation is mostly done. But
Sure.
For us, with most of our ales, we see it in the first couple days.
Yep. Well, and I would assume too, I would assume too, if you're somebody that, you have a couple of packaged beers that you're doing, a couple of your big standards, and one is a hazy and one is a lager. I'm assuming that lager CO2 production window is going to be a little bit longer than it's going to be with that ale strain. You know what I mean? And so when you do go into a situation like this, you want to remember how many of those variables there are, right? So I think it's interesting, and I'm assuming there was a lot of, on some level, some data keeping, some tracking, and figuring things out as you go, because there are so many variables.
Yeah.
So the next thing that I'm kind of been jotting some questions down as we go, and they're all very on the functional side. So you have the recovery system, and then I'm assuming there has to be some bulk storage tank, right? Because from your recovery system, you are taking that gas, and you could add in some steps here for me, but I'm going to give you the nutshell of what I think might be happening, and it's going to be very rudimentary. You have the input of the gas. At some point, that needs to get cleaned / scrubbed, purified, and then condensed again. Okay, back into a liquid. So this is how science works in my brain. Okay,
Sure.
and then it's going into like a holding tank. How childish did that summary sound? And what are the other inputs that we need in order to kind of just high level understand what's happening with that unit?
No, that was actually pretty good.
See, it's
we
why I
like
have
to
the
use
shiny
the
mic.
washing
You know what I mean?
Yeah, but we like to say, we want to make it like a washing machine. You go to your big box store, you pick one of these up, you bring it home, and you plug it in. It's not quite that simple. But I mean, from the scrubber, a key thing that we have is we don't, or another thing to look at is we don't have carbon filter any longer on our systems. We bring the gas in. Ultimately, we have a 3-stage patented compressor that was designed by Kim Dalum, and at each phase, that gas comes out at there's different things happening in each phase, but basically, you come out at 150 psi, then 300, and then ultimately towards the end, you're coming out at almost 600 psi.
Mm-hmm.
So the advantage of that is with science, the higher the compressed of that gas is, the higher the temperature in essence that we can condense that. So that's why we're able to use your house glycol. So basically, if your glycol is anywhere between 28 to 34 degrees, it will condense at a higher temperature. It's not going to be as efficient, obviously, but we can get that gas out in a liquid form in that phase. And there are dehydrators in there that are going to dry it out and clean it. And there's 2 of them on our system. That's something else to look at if you're researching CO2 collection. And then ultimately, yes, it does go, becomes a liquid, and then we do. And the advantage of our system is when it comes out at that high PSI, we can go directly into a bulk storage tank. We don't need a booster. We don't need anything else. At 600 psi, we can shoot that liquid right into your bulk storage tank.
Okay.
But Peter and Shane can probably go into a little more detail of what they do at their facilities. The bulk storage is the biggest. There's so many breweries that want this. This is another conversation for another episode. But bulk storage and CO2 contracts with your existing suppliers is a major problem.
It is. Yeah. I have some, I have some friends that have like the most lovely, generous, son child hearts. But if you want to see them turn a corner, start asking them about their CO2 contract, but we won't be naming names. But
Yeah.
so one of the things that I was thinking about as we were talking about this, again, so I think about things in very practical terms. We talk about a glycol input into this unit. And so in my mind, I start thinking, okay, so there's some additional demand on the chiller. I'm not a chiller guy, but would you say it's similar to saying, okay, we're adding another tank to the cellar? Would that be a comparable way of thinking about it? Because on some level, you are going to be adding load to the chiller, right? Is it a larger demand than that?
Eric, I'll let you take that.
Yeah, I think Eric might have a more particular answer. We were concerned about that, but my understanding was it was pretty minimal, at least on our scale. We knew we had plenty of capacity for more large scale tanks at our facility, and so when talking with Eric and the engineering team there at Dalum, it was seemingly insignificant for our scale with our chiller. But something
so is it just tied into your cellar loop then? Like that's how that, okay, okay. For sure.
Yeah, if you figure out a micro through a craft, if you figure out 125 gallons an hour, you're going to be because remember that our system, I know this isn't, I don't want to put on a sales pitch though, so so this is hard to explain because the advantage that we have is our system is not always on and it's not always off. Okay, so it's variable. So we're reacting to the flow of gas coming into the system. So the flow of gas and how you're brewing and how we're collecting that is going to dictate everything else. It's going to dictate your water usage, your power consumption, and your glycol usage. So that's the hard answer. We figured at roughly 125 gallons per hour. It's not a big draw on your system. We do have breweries that they just have no more capacity. And in that instance, we'll actually spec a separate chiller for them for the glycol. But again, there's no onboard refrigeration to this, so it's very minimal usage.
Okay.
And I can say that for size, practical knowledge, very similar to Peter. We're just operating at 200 barrel fermenters, and hooking up to our system was pretty invariable. But yeah, if you're running a 10 barrel system, 20 barrel system, you might have a different experience.
Right.
Okay. So I think about, again, whenever I have discussions like this, I always think about like the how is this going to affect me, right? Like as the brewer, right? Always looking at it through that brewing lens. I had the experience of most of my career has been in smaller pubs, 10 to 15 barrels. Everything's manual. And, I mean, the thing that can break is basically either your heat source going to your kettle or a pump, right? And then the last brewery I worked at, they were doing 8,000 barrels a year. Everything was automated. All the valves on the brew house were air actuated, and it was a big adjustment for me, right? So when there's a lot of things that are really very beautiful about that, when everything's working well, things like that. Let's dip into kind of the maintenance troubleshooting side of this, because as great as the automated valves were and that 30 barrel brew house that I was working with, when things weren't working, they weren't working, right? So every time you add a new piece of equipment, it has its ups and downs. Can we talk a little bit about maintenance with items like this? Is this just something that you're basically dropping in the corner of your brewery and forgetting about? What are the things? How do you have to be interacting with this piece of equipment on a week to week or month to month basis?
I mean, from a equipment standpoint, I'm not going to. I can definitely not say that there's never ever going to be an issue.
Of course not. Of course not.
You know, so the and Peter can attest to this. Right now, we had a couple snafus at Sebago in the beginning. I don't know what I haven't heard anything from Luke or anybody at JuneShine as far as we had some start on a restart, but that's just usually computer. You know, just getting everything up and running again. But you know, I'll let as far as maintenance on our, because we don't have a lot of moving parts. Your compressor, we're oil free, so the seals are non-lubricated, and they're not made specifically for us, but they are in a sense made for, you know, designed for this compressor. So you're going to have that, and we usually generally do the overhaul on that based on revolutions, and we can monitor that through our through the PLC, HMI, and what have you. The only other really part that we have is the desiccant that's in our dehydrators, and
what is that?
Desiccant, think of it as you go buy a pair of shoes and you have that little pouch in there with it that keeps everything dry. I mean, that's in essence a desiccant. So we have two of those. They are heat activated, but you know, it does act as a dryer, and there's nuts on the top of that you literally will unbolt, and you put a shop back on, and you suck out the old desiccant, and then you put the new desiccant in. But again, that's, you know, maintenance on that is all going to be dependent on your brewery and how often you're doing it. If you're full bore all the time, it could be every, you know, 9 months to a year. It could be 18 months. You know, and again, a lot of that we can tell by how much gas you're processing through CO2. But as far as everything else, I'll let Peter and Shane speak about their experiences so far with it.
Yeah, and I can hop in on that. When Chet from Dalum came out to commission for us, he went through some of our, you know, the routine maintenance stuff, and there's a handy check sheet of, you know, monitoring your gauges once a week and your temperatures, whether you're looking at the machine or using the digital platform to look to make sure everything's within range. And, you know, so daily, weekly kind of checks that most of us in the production side of things do really well for the first couple of weeks. And then 6 months later, you're like, oh, when was the last time anyone checked the operational, you know, pneumatic pressure feeding the PackTech machine? I don't even remember what it's supposed to be. So there's a lot of that stuff that you kind of take for granted once you get familiar with a machine. But like Eric was mentioning, the routine maintenance stuff seemed, you know, fairly straightforward as far as, you know, the prescribed things that need to be rebuilt as far as the compressor seals and that desiccant change. There's a water filter screen on there to probably monitor maybe more frequently than I do with my, you know, well filter at home or not. But we ran into a couple things that, you know, aren't really any different than what we've seen with a lot of other equipment, where you get a solenoid that's bad and then troubleshooting it. So, and that was essentially what, you know, was one of the hangups that we had earlier on. And, you know, essentially trying to troubleshoot that the same way you would, like you said, Adam, with, you know, a brew house that, you know, you're outputting 8,000 barrels a year. You've got technology. The more, you know, electronic components you have, the more electronic components can fail. And whether it's, you know, just because you got a bad one or you're using the device incorrectly or whatever. So we had a solenoid that essentially stuck, and, you know, it, you know, needed replacing and caused, you know, a little failure because of that. But I mean, that it's not really that different than anything else we have with, you know, any other machine in the brewery. We felt a little tender getting into it because, like Eric was talking about, we're dealing with 600 PSI of CO2. And that was one of the concerns when we started talking to our crew. They're like, so all of a sudden we're going to be interfacing with this thing that's got this like hyper pressurized stuff that's going to cut our fingers off and freeze our bodies if it leaks. And to put
that's it though. I mean, that's going to be all it does.
But and then you remind them that they're operating a forklift and the hydraulic lines that are 3 feet in front of them are much more than that. So it's a lot of it is just kind of that perspective. It's like, no, this is, we don't really interact with that high pressure cold stuff. That's not really where we interface with the machine. Most of our team is just hooking up hoses to a manifold in the cellar.
Sure.
So there's not a lot of direct interaction with the main plant itself. But I think it's important to have a team that feel comfortable being able to troubleshoot things. And if you have any folks that, most equipment now, apart from probably some of those older brew houses there and older equipment, like people are getting more familiar with HMIs and how to gauge what's going wrong. But we had a lot of support from the Dalum team, just trying to track down what is essentially a pretty basic thing that can go wrong with a lot of other stuff. But the scary high pressure things are, we had pipe fitters come in to help put in those lines, but essentially that stuff was pretty straightforward, and we don't really see us probably having to have any of that work readdressed for years to come. And that's really beyond the scope of any sort of daily operation anyway.
Well, and I think it's funny. I think sometimes you get desensitized to the fact that you are working in a brewery. It is a legitimate production space, and there are dangerous things, right? I went to an OSHA training this past summer, and it should have just been renamed "Everything Can Kill You." Because it is one of those things where it was like, is this like a scared straight program? Like, are they trying to stop me from a life of crime here, or what? It was, but to be mindful of the fact that, you do have to be wearing whatever. But that's where my mind went when you talked about some of those things. But I think sometimes we forget that we're surrounded by stuff like that in these breweries, right?
And we kind of, it did allow us to, installing this kind of reminded us some things that we probably could be doing better just in general in the facility. When we started hooking this up, we're like, oh, well, what if something does, like one of our hoses on this thing, disconnects, or if the tank that we're now collecting into, if this starts feeding into the brewery another spot. So, we've added, and also the equipment came along with additional CO2 sensors. If your facility doesn't already have them, we made sure that when Chet came to commission ours, we have a sensor right near the machine. And also these buffering tanks that we collect into, they also have a PRV that vents outside. Part of the, part of how we made sure to follow up with the Dalum installation instructions is to make sure that when you do this, that if there was some sort of valve that gets stuck, that you're not going to fill your facility with CO2 from the tank outside. But it's the sort of thing. It's like, guess what? We also already have a bunch of other CO2 lines before we did this install that we probably haven't put the same amount of care or thought into, because you just, like you're saying, Adam, whether you're desensitized to it or you're thinking about a lot of other things, we know there's a lot of hazards in the brewery already. And when you get a new piece of equipment, it kind of jumpstarts you to think about, oh, what are these new hazards? Oh, right. What are all these existing hazards too?
Sure.
So, but I feel like with this situation, it isn't really a new risk. It's just it's a different flavor of the same kind of risks that you deal with already in an environment that uses gases. Certainly.
Well, I'm wondering, Shane, if you can speak to, again, I'm somebody that has, like, I think of things like very functionally. And so when I think about CO2 recovery, I think about it on a batch to batch, like in a batch to batch way. So when I ferment one 60-barrel fermenter, do I recapture enough CO2 to, if I'm somebody that does CO2 transfers and carbonation, are you reclaiming enough to finish transfer that one batch from its own fermentation?
Yeah, I think it'll depend on kind of like what size system you're working on as far as like recovery,
Okay.
you can kind of expect about 0.4 pounds of CO2 per Play-Doh fermented. And
Okay.
so if you are able to calculate, how much CO2 you actually need to purge these vessels and do these processes, then you would be able to figure that out. But that's going to depend on what size machine that you are recovering from, and if it's going to be able to handle that full fermentation or only parts of it. Yeah, sorry, somebody called me during the
No, you're good. You're good. Well, this is the crazy thing about this is, and I kind of hinted at it before, but it's dawning on me. So you said 0.04 pounds of CO2 per Play-Doh.
Yeah.
See, I've never even thought about those metrics or what's like required on the backside to like handle that. That's one of the inputs that I've never really thought of. And I do think it speaks to a little bit of the blind spot that we can have as brewers of, I have a bulk tank that I get filled, and when it gets low, somebody refills it. Like you don't even me personally, and maybe it was just because maybe it's something I could have been more mindful of. Now I tried to make sure that I have effective but reasonable practices in the brew house. You know what I mean? But it's just one of those things where you just always assume it's the cost of doing business, right? With the tanks low, fill it back up. So that's interesting though, thinking about those inputs very specifically. So for on the production side, fellas, what have you essentially been able to go, you're not ordering CO2 from anywhere anymore? Is that how this system works, or is that how you intended to have your system work? What does it look like?
So I could say for us, and a big reason why we chose the Dalum unit is you can scale up with it, and so you can chain them together. So you can start out with a smaller unit, or just kind of planning ahead of roughly how many barrels of alcohol you're going to be producing per year. You can calculate how much CO2 you can recover and start maybe recovering a quarter of it when you have the funds. And then kind of as you get more funding and maybe more space, you can tie in these other units. So right now, we're only slated to recapture about 250,000 pounds per year. And we intend on growing that number and eventually becoming fully self-sustaining. So we're currently still purchasing CO2, but the long-term goal is to purchase more units and tie them together.
So what percent of your CO2 usage have you replaced with the Dalum unit?
I'd say it's probably about 20% right now.
Excellent. Cool. Peter, what about on your side?
So we were looking to scale a unit to be able to become self-sufficient with it, knowing full well that it's not going to be the first day that we get it that we burn the contact information for our CO2 supplier. And we've had a very good relationship with our gas supplier. We've been longtime customers, so I'm not here to burn them. They've been great for us. We know a lot of people struggled. And that was one of those tricky conversations, is that, we're looking to not buy gas from you anymore. However, it's not all of a sudden we don't need it. So, but that was our intent, was to make it so that we could produce or capture everything that we were going to need. I mean, we have one flow meter in our facility that measures how much CO2 we use, and it's for part of our filler. So trying to gauge exactly where we're using all our CO2 is difficult. We have a gauge on our telemetry that attaches to column inch measurement on our bulk tank from our supplier, so we can kind of see the rate at which we're going, and that's pretty dynamic. But so we've probably about halved our usage so far, if not more, by using collected gas, and it's been a little bit tricky for us to get started and to really maximize that during the slow part of the year. Where we kind of, as soon as we commissioned this, we were still, packaging a bunch of product from beer that we had already produced. So we're essentially starting at a deficit of where we're using gas. But we expect to, after being 1 year in, to have a lot more headway to feeling like we've got a better idea of whether we're generating a surplus or if we still need to, have an additional source. And one of the other parts that we're looking at into there, and I'm not sure if this is something, Shane, you folks are dealing with, is, there's the addition to, co-packing or other RTD beverages that a lot of producers are starting to do, where you don't necessarily generate CO2 from that sort of production. So we went into this with the idea that we wanted to become self-sufficient, but also with the understanding that depending on our practices and if we pick up some other beverage production, that we won't necessarily be able to be sufficient with our present practices with these other products that are coming up. But I think we're going to cover the ground of our beer production once we really get into the meatier part of the season, that we can collect and get some better data on that.
Definitely.
Yeah. I can kind of attest to the RTD production. So I don't think I mentioned, but JuneShine makes hard kombucha and cocktails in-house. And so I think we launched our cocktail program, I believe, in 2022. And it was during that time we saw a spike in CO2 purchasing, because you're not capping tanks or anything. You're fully carbonating basically city water, and also purging it of any oxygen. And so that was also a huge factor of expecting we're going to be making these brands for quite some time, to start investing into getting CO2 from other sources.
Yeah, that's I don't know. It's interesting stuff. So just for the listener at home, and my guests are probably aware of it right now, I have a show sheet that has a lot of questions on it. I haven't really looked at it too much because I've just been engaged with the conversation, and I've been asking questions kind of along the way as they kind of spur my mind, right? And I prefer to have it like that anyways. But so without me, I guess, like, what are you thinking as far as what should I be asking you right now? What's some information that we haven't uncovered that we should probably talk about while covering this topic? And you don't have to listen. I taught for 10 years, and they say that you're supposed to give people 7 seconds in order to raise their hand as a teacher. Now, sometimes that can feel like a very long 7 seconds, but I know I'm just popping something on you out of the blue. So, feel free to pause. Hey, see what I did there? I just filled the time. You know what I mean?
Yeah, there you go.
Talk through
There you
it.
go.
And then it's like an improv group. You know what I mean?
Yeah.
So this is I mean, just for professionals. So Peter, go ahead, man.
So I guess I would maybe jump in with just a couple of the questions that people ask me a lot when I talk about it, and not just someone on the street, but people in the industry. A big question that we get is, oh, your electricity consumption is going to go through the roof. Have you noticed a big spike in utilities? And again, for us, that's we're open a little bit later on Sundays this year than we were 2 years before. We've got, other improvements in the building, all these other things. So it's a little hard to track with that. But I did review some of our year over year electrical statements, so that I've been, able to competently try and answer that. And it seems to have had a very minimal, or at least, with other changes in our production and our facility with attached restaurant, it does not seem to be something that has skewed our electrical consumption by any noticeable means. I am going to be working with Luke Truman, who works with the New England Brewers on efficiency and working to improvements or do environmental improvements and that sort of thing for efficiency. And we were going to measure some of the consumption of energy on the machine for electrical usage, but it's pretty minimal, I think, compared to a lot of the other equipment that we use in breweries. The electrical consumption is pretty low, I think, for what we generate. And I guess, there's two parts to that question as well. Somewhere someone is using energy to compress gas. So, environmentally, that energy is coming from somewhere, no matter whether we're using it or someone else is. But the other part is if we're using it, we're paying for it. So, but the cost of the energy, when I've been talking with the Dalum team, is very low per pound when you relate it to how much you have to spend to collect your own CO2. So again, that's one of the questions that people reach out to me a lot. And Shane, I don't know if that's something that you folks have seen, or if you get people wondering that on your end.
Yeah, I think I always encourage people at any level in any brewery, if you're a shift brewer or even just someone who washes kegs, try to work with either whoever you're working with as your manager, the owner of the company. Try to work with them and look at the utilities and how much that you're using. I think I've worked in a couple smaller breweries before, and it's never really a transparent thing of, hey, how much water are we using per year? How much CO2 are we using per year? And something that JuneShine has really opened my eyes to is from day one, we are kind of in this mindset of we want to clean up our own mess. We realize that by creating our beverage, we are creating, CO2 that's getting off-gassed. We're using water in a state that notoriously doesn't have any. And so start to ask those questions, and you don't have to have flow meters or anything. You can simply look at how much product you have made throughout the year, and then look at how much water you purchased that year, how much CO2 you purchased that year. And that'll tell you how you can start at baseline and then look at ways to reduce those numbers. So for us, obviously gas rates are going to be different in every state, but we're purchasing 12.7 pounds per barrel produced. And then our water ratio is 3-to-1. So for every 3 barrels of water, we're producing 1 barrel of alcohol. And
that number is good off the top of my head, right? I mean, that's a solid number, right?
Yeah, and there's just simpler ways to do it. This could be a whole nother conversation, but really think about sustainability, not just CO2, but look at how wasteful a brewery can be, and then start to make those small improvements. It doesn't have to be major changes immediately, but just really being conscious about it when you're in the cellar.
Yeah. And as far as, I can't speak for our competitors, but the Dalum unit, we produce, it's about 2.2 kilowatt hours to run the plant. We consume, if you think about John Kudrowski, who's our U.S. chairman, I mean, he's got a good analysis and basically, or comparison. I mean, think of a window air conditioner. We use less power than the smallest window air conditioner you could buy at a big box store. If you wanted to run our plant off of solar, you could. So there's a lot of, so the power consumption, in pound for pound in producing it, you're mentioning 12.7 pounds. The average barrel of beer between 5.5 and 6% is going to produce about 10 pounds of CO2. You'll lose about a pound atmospherically, and what have you. Then you have, like Shane was talking, efficiencies. So basically what it comes down to is, how much of that 10 pounds can you, reuse in your brewery? So yeah, not a lot of power consumption. So, a lot of bang for your buck as far as CO2 production.
For sure. Any other things that you're thinking about that we should talk as far as CO2 recovery goes, you guys?
No, I'll tell you what, it's been a pleasure working with these two. I mean, I think in the time I started working with Luke Sutmiller at JuneShine, he's had 2 kids and I've had 1 grandchild. So, so it can be a process.
For sure.
And and I remember, the first meeting with Peter and Kai up at Sebago, that was, we spent a good few hours talking just CO2 and recovery. So it's been a journey, and talking about even the questionnaire. Like if somebody gives you a questionnaire, that questionnaire can generate, as you said, Adam, it can generate a lot more questions.
Sure.
Because
sure.
I've done questionnaires and I'm looking at the CO2 recovery or the CO2 purchasing, and I've called them back and said, hey, I think this is supposed to be, is this 12,000 pounds? They're like, no, it's 120,000. And I'm like, oh, well, you're using about 4 times more CO2 than an average brewery your size. And you're not saying that to be a smart aleck. You're just saying,
yeah.
We're going to be able to make it for you, but there's not, we're not going to be able to help you a lot. So then they go back to the drawing board. It's like, okay, well, where's all the CO2 going? So it's because we have water consumption. If you're working on an ROI, if you're getting something back, if you're thinking about this and you're going to whether it's us or our competitor, I mean, make sure that you got to be looking at everything. You got to be looking at power consumption. You got to water consumption, glycols, the onboard refrigerant, all those things. I mean, you could be recovering a couple pounds of CO2, but what's it costing you to, what's it costing you to do that?
Sure. And I think kind of the last thing in my mind, which a lot of people would want to know is, and I know this is going to be a variable answer, right? But, you mentioned ROI because I do believe that I think it's great for companies to have sustainability goals as far as from an environmental standard, from a standard of being good stewards of our resources, right? But also we are businesses at the end of the day too. Can we speak to ROI a little bit?
Sure, I can start and then the guys can jump in, but obviously it depends a lot where you're at. Right now we're seeing price increases, especially in California right now in the Northeast. A lot of the breweries that I'm talking with, they're all seeing increases in their current rates. I have heard force majeure, shockingly, a few times over the past week or so. So obviously, the more you're paying for your CO2, the quicker it's going to be. But on average, right now, the ones that we put in the field, you're looking at on average, about 36 to 42 months on CO2. But Peter I think that Chet had you guys collecting gas in, about 24 hours and actually making CO2. CO2 recovery, it's kind of like the silent employee, after a period of time. It just sits in the corner and as long as we keep it operational for you, it's going to be making you money. It's going to start making you money from the day you plug it in. Mm-hmm. So that would be the goal.
Yeah, and I would say that timeline that Eric was saying, 36 to 48, that seems pretty sensible to us with the rates that we've got. And when Chet came and commissioned a machine with us, he was talking about other places where I think it was some island area where he was like, they had a machine that they put it in, it was going to pay for itself so fast because the rates were so so high to get gas to these remote places. So the more remote you are, the more it makes sense. Even for us with where we are, just, the investment turnaround is pretty reasonable. And it's funny, the feedback you get from, a variety of people when you talk about this sort of thing. And, you use the word sustainable and it can, people can come at it from different ways, whether it excites them or they think it's a buzzword that's pandering to another group or whatever. And, on a very basic level, it's a fiscally responsible decision. We think about this in the brew house where, early in the craft brewing industry, people be like, oh, we're saving the planet by recollecting the hot water we generate during our knockout for our heat exchangers so it doesn't get wasted. It's like, people aren't doing that to save the planet. They're doing that because they need hot water for the next brew. Yes, it's also great to not be wasteful, but you know, no one did that because they were hugging a tree or something. It's great. And the same thing with your spent grain. It's like, you know, if it's going in the dumpster, man, that's a bummer. You know, I know there are places that have to do that because they don't have agricultural other places nearby to take it. But, you know, there are ways to just not be wasteful. And it's, you know, whether you're coming at it from, you know, a desire to, you know, be your best steward for the environment and the resources, and also to be the best steward for just, you know, spending money wisely and not being wasteful of, you know, your financial parts. So there, you know, it's beneficial in both those ways. And we had someone that they reached out to us and they thought we were putting this in to, you know, reduce our carbon emissions while China was not being governed at all on what they were doing for their CO2 emissions. We're like, well, okay, that's not rare. Yeah, that's not everything we're about here. Yes, we're producing gas, and right now it's just disappearing, and we're buying that same gas at the same time. Why not just keep that gas and use it? And it's also beneficial to the environment now that there's technology scaled for us to be able to do that, and we've got the, you know, a financial gain from it. So it's, you know, the return is great for the financial investment, and it's, you know, great for the environment as well. So it makes a lot of sense just now that there is technology that can work for folks our size.
Yeah, we like to say that, you know, our goal is to make you CO2 independent. And the byproduct of that is, you know, we're more sustainable for the environment. So, I mean, ultimately, we're coming from the business standpoint. It's like, what can we do to try to get you CO2 independent? And there's, like we said, RTDs, you know, whether you're canning, you're bottling, there's a lot that goes into that. But I mean, that's our goal. And the byproduct of that is, you know, it's better for the environment. So, but strictly from a business standpoint right now.
Well, gentlemen, I got to tell you, I really enjoyed the conversation. I really appreciate the time that you gave me today. If we can give everybody just a quick shout of how can we you know, follow what's going on with your brand, give them the channels that they can kind of track you guys on, and we'll go from there.
Yeah. So part of JuneShine brands, we have our JuneShine hard kombucha, and then we also have our canned cocktails, as well as we recently acquired Flying Embers hard kombucha and cocktail-based seltzers that are available nationwide, about 30 different states. Instagram would be JuneShine or Flying Embers. We also make Easy Rider beer offsite. It's distributed in Southern California, and same tag name for the handles. But any kind of, most of our products you can find at your local kind of health food store would be like a Sprouts or Whole Foods. We also make a non-alcoholic kombucha that's in Whole Foods nationwide.
Okay. And again, we're strictly pretty much in Maine, apart from some friends in New Hampshire. But so most of the folks around here know us at Sebago Brewing, and then also our RTD brand Revel Coast, as well as an alternate beverage we're working with called Mystic Cove. But if you aren't in New Hampshire or Maine, you should come on up and visit us, especially in the summer or during ski season.
Awesome.
Yeah, and then Dalum Beverage Equipment on LinkedIn. You can. We have a ton of information on LinkedIn. We have the Dalum Draft, where we have great articles written by our host of engineers and industry experts. Facebook, Instagram, Dalum Beverage Equipment or Dalum Equipment. You can catch me. I'll be over in New England next week at the New England Craft Brewers Conference, and I'll be in San Diego for the San Diego Beer News Awards. I believe it is on the 20. It's got my days mixed up. I'm on a plane a lot lately, but I think it's the 25th. Nice. So I'll be in San Diego for that. But yeah, you can reach out to me, hit me up on email or what have you. And
yeah, and Dalum has a YouTube page that I was able to hit up too, and check some stuff out as well. So if you want to get some visuals and some different things, you can jump on there too. Well, gentlemen, once again, this was really great. I really appreciate it. Hold on until after we drop off here real quick. But everybody out there, I am going to be back live in your ears on Wednesday next week. I'm going to be talking to John Haggerty of Warped Wing, so you're not going to want to miss that. I'll have the promo stuff coming out for that shortly. And as always, show a little love to my wonderful sponsors, Blickman and Brewed Fiscally. Genuinely grateful that you all tuned in. Be good to your people, and we'll catch you next time. Have a good day, you guys.